Okay, good morning. Welcome to
FamilyMath number 850.
FamilyMath850. So today we're going to be using a recent blog post from Joel David Hampkins on drawing an infinite chessboard. It's going to be just kind of a fun drawing project today. So I saw this post actually by Patrick Honor, and then learned a little bit more about it. And one of the neat things is he says right here, it's something you can actually do right now. You can make this drawing. So what do you think about this drawing?
It looks like a pretty hard drawing to make.
Yeah. What do you think about it?
It looks like a pretty good drawing.
Yeah, that's true. It also does look like a pretty good drawing. And so he gives some step-by-step instructions on how to do this. And it uses a concept called points at infinity. So it might not show up super well on my picture of this, but there's a point at infinity there, one there, one there. And also later on, when you go to make this, add a little bit of depth for the final picture, scrolling all the way down here. Here, you're going to add a point of infinity down at the bottom of your picture as well, and have these lines all pointing at that point of infinity.
All right.
Oh, look, there's another one. So what do you know about points of infinity?
Well, so they're points that I guess like the lines kind of originate from.
Okay.
Or go to, depending on how you look at it.
Yeah. Yeah, and so you can see, for example, in this picture, that the lines, some of the lines are all converging to a point that must be over here.
Yeah.
That there's a point sort of in the middle that you can imagine the diagonal of the chessboard goes to.
And then there's a point over that way.
There's a point over here. And then these lines are all pointing down to a point that's kind of at the bottom.
Cool.
Yeah, so what do you think? Do you think this is going to be easy or difficult, or what do you think it's...
I think it's going to be doable.
You think it's going to be doable? Okay, what does that mean?
I mean, it might be kind of hard, but I think we'll be able to do it.
Maybe it's just like a little bit hard.
Okay, cool. What sort of math do you think is behind this? Like, why are we doing this as a math project? Or why did a math professor, which is what Joel David Hampkins does, think this was interesting to write about?
Maybe with the points at infinity, there's some math connection there.
Okay, maybe with that. Any other math connections here?
I can't think of any right off the top of my head.
Well, with the chessboards themselves.
Yeah, you can do a lot with chessboards.
And then this is another branch of geometry called perspective geometry. Mm-hmm. So on a real chessboard, all these squares would be exactly the same size.
Mm-hmm.
But when you're looking at a chessboard,
they're not.
Some parts of it are closer to you than other parts. And so getting it correct on how they sort of shrink in size as they go away from you is actually a fairly challenging problem.
Yeah.
Okay, so I will leave this open I'll leave this open for you to follow the directions on, and I'll have you off camera make your chessboards, and when you're done, we'll talk about them individually and about how it worked out for you. All right?
Yeah.
All right.
Okay.